Welcome to the who, what, where, when, and why of exoplanets with me, Didier Queloz, astrophysicist and Nobel Prize winner. I think the big discoveries these days about exoplanets is not only the fact that there are plenty under the stars, it's the fact that planets under the stars look quite different from the one that we have in the solar system. And I was completely a surprise on this. We have planet that doesn't really fit into the usual category. In the solar system, we have three categories of planet. The rocky planet, like telluric planet, Venus, Earth, Mars, Mercury in a sense. And then we have the giant planet, Jupiter, Saturn. And then we have what's called ice giants, which is a small giant planet a bit further down, further away, which is a Neptune and Uranus. The planet we've detected, they're kind of a bit along this line, but they are also different. Because some of them, they are bigger than the Earth, smaller than Neptune's. We call them super Earth, mini Neptune. We don't really know what it is. We have also planet bigger than Neptune, but smaller than Saturn. We have also planet bigger than Jupiter. So there is a whole range of planets that we never thought would be possible. I know we have to bring all that together and to understand why so. Why do we have so much diversity? Why the solar system is the way it is? Why the solar system is so extended, not compact like most of the system we're finding? We don't have answer to that. We have some clues, we have some ideas, and we're also missing a big part of the story. So the planet doesn't have real names because we don't name stars in astrophysics. We have an identification of a star according to the catalogs, and some of the catalogs are very old. Arabic names, Greek names, then we started to add numbers, and then we had another numbers, and then now we have the Gaia numbers, which is kind of fun numbers, very long. So this is the way we just identify stars, and then we identify the stars according to the position in the sky, which is very accurate. Now, when you find a planet, you add just a letter, which is B for the first one, C for the second one, D, and so on and so on and so on. So you use the name of the star, 51 Pegasi, because it's Pegasus constellation, 50th number stars of the Pegasus constellations, and B, because that's a planet B. Why did we say 51.B and not 50.A? Because by construction, it comes from the binary star time, and the A was the letter reserved for the primary object, which in that case would be the star. So if you want to be formal, the star, you call it 51 peg A, and the planet 51 peg B. That's how it works. As of today, I didn't check the official catalogs of the number of planets, but there must be about 5,000 known planets. We have to divide here as how many planets there are and how many planets we have detected. So we have detected about thousands of planets, but we're missing a lot of them because we are limiting in the way we detect. A lot of this planet has been detected because they're transiting the star. So the likelihood of a transit is less than 1%. So for one planet transiting, you're missing 99 others that are not transiting. So we use detections to extrapolate about what's called the occurrence, which is essentially when you look at the stars, what is my chance that there is a planet? And the answer to that is almost 100%. So we know right now that essentially all stars have planets. What is interesting is to know what kind of planet. So essentially the idea that do we have planets under the stars is a solved problem for astrophysics. The distance in the universe is difficult to feel it, but they are really huge. They're really huge. Already the moon is so close. Well, going to the moon is not easy. That's why we have not been that often. So the idea you would travel between stars is not something we can really find, realistic. Certainly not as a biological entities. We're very fragile. Space is death. We cannot do anything in space. We really design and fit it to stay on that planet and to take care of that planet. The idea that you would get into a spaceship and then you would go to another planet, I'm afraid it's unlikely it's going to happen. Dinosaurs. Countryside. Au bar. Cat.